All right, problem 8 says consider the vector field F, whose components are y minus x and x, and the circle C centered at the origin with radius 2 parameterized by the function r of t as 2 cos t, 2 sine t. We're letting t vary from 0 to 2 pi. Based on the picture to the right, make a conjecture about the signs of the circulation and flux of F over C. Then compute these quantities and interpret the results. All right, so you see that the curve is given a counterclockwise parameterization, and we have our vector field here in blue. And the regions where the angle between our force vectors in blue and the tangent vectors along our path is acute, that will contribute positive circulation. Okay, so I can see like in this region here, that's going to be positive circulation, right? Because of the angle there being acute. Now over here, okay, I see that now the force is acting against us as we move along our path. And there's an apparent symmetry here about this line y equals x for our field. So it feels like these two circulations should be equal but opposite. So we should get some cancellation here. And likewise down here. So it's feeling like the circulation should just be 0. Now the picture could be deceiving us, but at least from that alone, I would make the guess that circulation is 0. Now when you actually do the calculation, and by the way, this is a really good exercise. You may want to just pause the video and compute the circulation just to check, but in any event, circulation does come out to be 0. Okay, so now I have the field here, F is y minus x comma x. Here's our parameterization for our circle. F evaluated along that path, so I'm just replacing x with 2 cosine and y with 2 sine. So I get 2 sine minus 2 cosine, comma 2 cosine. Here's the derivative vector for r. And so to compute the line integral, right, take f evaluated along the path dotted with that derivative vector. And when you do that, you wind up getting these expressions. So I see a cos squared minus sine squared, and I can use the double angle identity there to help us integrate this. That's just cosine of 2t. And then sine t times cosine t, I can also use a double angle identity. That's 1/2 sine 2t. So you wind up getting this combination of sine and cosine of 2t, and integrating from 0 to 2 pi is just going to give you 0. So yes, in fact, the circulation is 0 as the picture suggests. All right, so now let's go ahead and look at the flux. Okay, do we think that the flux is going to be positive, negative, or 0? Well, now for flux, right, we want to look at the angle between our blue vectors and the normal direction, right? And keep in mind that the parameterization of the curve is counterclockwise. So based on our convention for the unit normal vector, that means our unit normal will be pointing outwards. Okay, so for example, in this region right here, these blue vectors, right, are pointing nearly perpendicular to the circle, but they're pointing inward. So this is going to contribute negative flux, okay? And likewise over here. But then in these regions, okay, now we're pointing nearly perpendicular out of the circle. And since we're out of the circle, that's going to contribute positive flux. However, this negative flux stuff here and here is definitely going to outweigh the positive flux portions, right? Because the magnitudes of F in these negative flux regions are much greater. So it feels like the flux should be negative. Okay. And if we go ahead and do this calculation, okay, again, you get these trig identities to kick in. Here, the double angle identity, once again, sine t, cosine t is 1/2 sine 2t. Here you get a cosine squared, okay, which is 1/2 times the quantity 1 plus cos 2t. So use those to help you integrate. One other thing there, remember for the flux integral, we're going to take f evaluated along our path dotted with this r perpendicular prime vectors, right, that I introduced in the last video. So that's where I just take the components of our prime and I swap them, and then I just stick a negative in front of whatever this x component is. Okay, so you do that calculation, and yes, you do get a negative value. You get negative 4 pi in this case. All right, that's going to do it. Thanks.